Let me start recording this, it is recorded now. Yeah. Okay. Good afternoon, everybody. Good to have you all. Always a pleasure hosting teachers from the IPN network. And as a matter of fact, Dr. Maria, we recently came up with our national education policy in India. So after 34 odd years, India as a country came out with the new education policy. And obviously the policy lays a lot of emphasis on the scientific temper to be developed for the kids, young age kids in India. We have always been a country which has loved its mathematics, if I may say. So from the Aryabhatta to a lot of other people who were great sort of a mathematician in Indian context. So I'm sure you are among a very interesting audience. So don't worry, they'll make you feel at home. And I'm sure we are having a great sort of a session ahead of you with given sort of an expertise you have on the table. I am sure of an interesting session. And for the very brief introduction of Dr. Maria, I will not even attempt her second name, which I have already taken, I would say, liberty, that I will not attempt her second name, which is interesting. And she will tell us what is her interesting name as we go along. Okay, Dr. Maria focuses her research and development efforts on learning communities, largely informal education, online education, advanced mathematics for young children. That is her largely, if I may say, area of expertise, but then for the young children and game design. She holds a PhD in mathematics education from NCSU and MS in mathematics from Tulane. Dr. Maria is a founder of Natural Math, an educational design, consulting, and publishing company, and Natural Math Alliance, a nonprofit educational organization. Her approach to teaching focuses on easy complexity, such as calculus for 5-year-olds, openness, and kindness. She authored Moebius Noodles and Avoid Hard Work, popular books with innovative math activities for parents, teachers, and math circle leaders. So that's her brief introduction. I, on behalf of the entire IPN community, Dr. Maria, welcome you to this session. And as I said, you're now sharp at 4 o'clock. For the benefit of all our members who are joining us today, who have just joined us, I would request firstly, do not cloud the chat window by good afternoons or good evenings or your introduction. We will leave it for some other day. But having said this, only for asking an appropriate question. Yeah. So I have just muted the other participant, Dr. Maria, and you have unmuted yourself. Thank you very much. So obviously, you know, we have to create a little sort of a decorum in going. So my request is that I have for now muted all of you. However, since we are experimenting with this method wherein after every 10 minutes or after a block sort of a presentation, Dr. Maria may have to ask you all questions. Okay? So my request to start with is that if we have to make sure that format is successful, we have to ensure our audio or our environment is conducive. So if you're at a location or at a backdrop which has a lot of noise, this doesn't work. And even in one atmosphere that is not working, it will not work for us, okay? So in order to keep this interactive, I request all of you for another 1 hour to 1 hour 15 minutes, please place yourself in a location wherein you have a sort of pin drop silence, if I may say. Okay, Dr. Maria, welcome to the session. Good to have you with us. Over to you, ma'am. Yeah.
Hi, everyone. And thank you so much for coming. I'm so excited to meet you. There is always more expertise in the audience than in the presenter. And I hope we'll make it active today and play together and learn together. My presentation is about calculus for 5-year-olds. So please get in touch with your inner 5-year-old and play like you are a child for a while, but also channel your teacher, parent, and education leader, grown-up persona. It will be fun, I hope, joyful and meaningful for us. I'm going to start the presentation for a while, and then I'll pause and we can talk together again. So I'll talk and I will share my PowerPoint and start it from the beginning. So now, let me just make it work. Here we are. We just hit 200 participants. Welcome, everyone. I am Maria Droujkova. I grew up in Ukraine. You can probably hear it. Right now, I am in North Carolina, USA, at my home office talking with you. And I hope you can hear and see what is on my screen. And this says 5-year-olds can learn calculus. So you can start arguing now, or you can wait 10 minutes until we do questions. But usually when I say that, people pause, and then I get surprisingly friendly response. So let me talk a bit about myself, and then we'll see how it goes. So I do a lot of activities called mathematical circles. They are groups that people get together for love and do informal mathematics together. And sometimes they are for older teens, sometimes they are for toddlers with parents, all kinds of formats. Sometimes they are large and sometimes they are small. And that will come in handy when circles is an international movement, and it's connected to mathematical festivals and mathematical Olympiads, which are two more formats for doing club mathematics and formal mathematics, however you want to call that kind of mathematics done for love. My company, Natural Math, is started in about 1996, one of the first companies on the internet doing mathematics. We publish books, and I'd like to tell everyone that all our books are Creative Commons, which means they are open license, which means everyone can just get their copies, and for educational use, it's open. We have been featured as one of the best projects in education on Team Open, the Creative Commons site. Do you see all of my slides? I have a lot going on the screen. Do you see it all right?
Yeah.
Okay, just checking. And we also do research and development and consulting for different groups, design games, help people write their writing projects like encyclopedias. We worked with NASA on their virtual magnet and so on. And do a lot of outreach like Mathematics Festival. And that is probably one of the most viral article about us from the Atlantic called 5-year-olds Can Learn Calculus. So we'll try some of that. And I want to confess, I love and respect Matific. And Matific is a company creating games, helping people to learn mathematics through games. So I've been involved with Matific for a while. And today, I want to talk about the number one reason I like Matific. And that is, it's designed for love. Now, we all know schools involve compulsory education, as in children have to get their school education. And yet we can design for love, we can design for people who want to learn in mind. And that creates a different design, and it has a lot of design connotations. So doing what I do, I tell people I do math, and a lot of, I know India has a big mathematics tradition, and I use some of ancient Indian mathematics in my work. I want to thank everyone and your ancestors for developing this. We make mandalas with children sometimes, and Indian people in the room help with that. We do some Vedic math. But in the US, especially when I talk to people and say, oh, I work in mathematics, people have this reaction. They start breathing hard. They start crying sometimes. And I get to hear a lot of these math grief stories. What happened? Let me tell you all about what happened to me in 3rd grade. It was horrible, and I've been hurt, and I never can do math again. And children, as you know, often ask this question, why do I have to learn this? They just ask us, why this? And of course, why? We tell them, well, mathematics is so useful, we say. It helps us to fly to Mars, helps us to build roads, helps us to put our food on the table. And of course it is. And then we can tell them, well, it's also fun. It's beautiful. We can make beautiful things with it. We can make wonderful, interesting activities. We can solve puzzles. And this is true. But that's not why they react like this sometimes. It's not because they don't know someone somewhere finds mathematics useful, or that someone somewhere is having fun. The question is really, why should I do here now? Why should I do this now? Why are you making me now? And that's where I have this concept of designing for enthusiastic, yes, where you try with your design, with your teaching, with everything you do, to design with a purpose in mind that children will love it, will like it, will choose it. And that really changes how things are. And that was one reason I support Matific in particular. They have that design principle. They design for people liking it. So that why question really is about consent in a sense. And if you imagine your student volunteer, one of the principles is choice. So, okay, if you remember just one thing from this presentation, just the one, always do mathematics with a lot of color. So I have my favorite box of colored pencils here. You can hear them. And I hope you can get a piece of paper and a pen. And I hope it's your favorite, because we're gonna do an activity together. So I'll wait for 10 seconds, get a piece of paper and a pen. We'll draw something together. If you have it handy.
Yes, let's get going. Good.
Yes, now time to channel your 5-year-old. And that is something people always ask, well, how do you do calculus with 5-year-olds? Well, we're gonna try a thing. So on your paper, draw a square in your favorite choice of your pen. That's your interesting choice now. And once you draw a square, well, that's not my choice other than the color. I want to ask you to draw a little triangle on top of the square. My triangle is a right triangle, and I chose to do the square in purple and the triangle in red, as you can see. If you have a box of colored pencils handy, you can choose different colors. If not, just do it in your favorite pen. And once you have that, Pratik, I see you raised your hand, so please wait with questions. I will pause in about 3 minutes from now. So hold your thought, please, everyone. Write it down on your piece of paper so you don't forget your beautiful ideas. Beautiful ideas. And now, on top of that triangle, that every 5-year-old will say, oh, that looks like a little house. You draw two smaller squares like that. I choose green, you choose something else maybe, or your favorite pen. And once you draw that, you pause and celebrate your beautiful art. Now it doesn't look like a house much anymore, but something else. And then I will invite you to kind of do the same thing again. The same thing as in draw little triangles on top of these two squares. And soon enough, if you keep doing it, so you can try doing it for a couple more options. So we were here, on top of those squares, draw little triangles. On top of the triangles, draw more squares. And you can keep going while I'm talking even. And hold your questions for just a moment and keep it where you won't forget it. So the structure, if I do it with children, they notice, oh, wait, you can keep going. And some other says, no, I am bored already. I want to stop at this, just 3 levels. And and then I ask, well, can you keep going on and on and on and on? And some children say, no, you'll run out of paper. It will get too small. It was already getting too small for me to draw. And others will say, yes, you can. Why? Just imagine this. So I said, that's an interesting choice. About half people like to imagine this in your mind going on and on and on. Another half people would rather not imagine such a thing. But that's the idea of infinity. This structure is called the fractal. And this in particular is called Pythagorean fractal. And of course, if you can draw a triangle and a square, you can make that thing. That's an accessible art piece for 5-year-olds. What makes it more accessible even, and here it's colored with more choices, and slanted triangle is another interesting choice. You can make it the tree slightly slanted, look at this. So beautiful small choices. Larger choices open up. What if you drew a different shape? What if I ask you, draw your favorite shape? Well, I told you to draw a square before, but what if you drew a triangle or a star or a cat, whatever your favorite animal person shape is? So add more choice. And children love doing that part. Even a small child can draw something. And then we can do the same thing to it, as in take that shape and add another level to it. So add little stars to your stars, little triangles to your triangle, and even little cat to your cats. And soon enough, this happens, your very own, very personal fractals that you made yourself. And every child makes their own. And of course, they behave differently. As they are slanted, they grow faster or slower. That one with 5, the star, that's a lot of stars on the 3rd level. And we can explore these mathematical differences in little tree fractals and talk about exponential growth. Everyone is studying exponential growth these days, even 5-year-olds. And here are real pictures of photographs of fractals people made, little children made, of different medium, Minecraft, pieces of clay, art. And this is an example of designing for love, for designing for people to make their own thing and to explore a very deep mathematical topic, which is fractals, infinity, limits, exponential growth, all put together. So at this point, I'm going to stop as I promised, and I'm going to invite questions either by voice or in chat. And some people were raising their hands, or maybe
you
they
can
were
ask
just
your
playing.
question. Pratik, you wish to ask your question, you can unmute yourself and ask the question, please. And anyone who is keen to ask the question, please have a show of hand. and then we can ask the question, or you can put it on the chat window. I can spell out that for you. Pratik, if you had a question, you can unmute yourself and then ask the question, please. Pratik, otherwise, Jyoti, yes, Jyoti, you can unmute yourself and ask the question. Jyoti. Yeah, go ahead. Jyoti, you have a question? Jyoti has a question, but interestingly, she is in the poor network zone, and Pratik has no question. It was I think by default, he clicked on it. Anyway, I think, Doctor, any other question, if we have, we can take it right up. Either you can post it on the chat window, ladies and gentlemen, or you can have a show. Shweta Agrawal.
So here is an experiment. It's called wait time. We're going to have 30 seconds totally silent. If anything, we will just rest and relax. But I would love to have everyone, all 200 of you, 300 almost now, to close your eyes or relax otherwise for 30 seconds. Formulate a question in your mind and then put it in chat. I will not get to 300 questions, obviously, but I would love to see them and we will pick some. So 30 seconds of silence and meditation. And now 30 seconds of typing your question in chat, please. Don't press enter yet. Or if you press, that's okay, but type your question. That's what I do with children. I say, everyone type something and then we'll press enter together so we all see it all at once. No spoilers. Okay, if you haven't pressed enter yet, press enter now. If you are still typing, please keep typing for a few minutes and then go ahead and send it. So I'll just start picking questions and I'll do that for the next 5 to 10 minutes and then we'll continue. And we can continue this conversation. Maybe I'll make a blog post to talk to everyone because I like every voice to be heard and to engage. So one question was, how can children relate to calculus terminology, all those beautiful words? Calculus has such beautiful words. I can't pronounce all of them well, but bear with me. My favorite is infinitesimal.
How we can make our maths class more interesting and innovative, which can give knowledge with entertainment for children below 3rd class. Thank you.
That will be next. So one is terms. Children love fancy words. So the best thing to do is have them play, hands-on, interact, make beautiful stuff. And as they play, you name things that they do. They make this creation out of clay. You say, oh, well, this is going to grow exponentially. See how it's growing faster and faster and faster. There is more to it, and now you are too tired to make the next level in clay. That's an example. So as people work and do things, work with tools, work with models, use words to speak about their creation, And that's how we introduce terminology. What makes it joyful and engaging? Choices make it joyful. So we had an example of an activity where every student can put some of their own in it. Play, actual gaming, actual play. So if you can present what you are doing, there are a lot of games developed for that. Usefulness does make it interesting. So if you invite every child to try and bring an example from their life. So for example, think of invite your children if you want to do calculus. What in your life that you know goes on and on and on and never ends? An infinite thing. And some children say, well, the sun always rises and goes the night and day. That never ends. That keeps going and going and going. And some one 5-year-old I know said, love never ends. And that was so beautiful. And some people say, well, we have a railroad in town and I go to the railroad and it goes on and on and on and never ends because they're little and for them, a few kilometers is never ending. And they say sometimes this lesson never ends. And I'm like, oh, I wish, but it will. So how to teach them tables in an interesting way? Tables is one of my favorite topics, multiplication tables in particular. And I think, again, modeling is a good example. You can do multiplication with, I will have some more examples with things like mandala, where it expands and multiplies, with things like examples from the nature, where you see radial symmetry, or you see the trees that branch and branch and branch, and you can invite every child to bring a model from home, and you explore that like a scavenger hunt. Their questions also never end. That's a good comment in the chat. Okay, how can we control talkative kids who have too many questions at the same time? Well, we can deal with them the same way we are dealing with many questions now. You invite people to work in parallel and to create something on their own based on their questions, and maybe to talk to one another and help their math friends with their questions. So their ideas are preserved, but it's not the teacher who deals with every one of them. Imagine we collect things together, we make collections. One of my favorite things to do in a physical space is to have a board. A board in the corner, just a piece of paper, and everyone who has a question can put one on the board. And then we get to some of them and children can put answers there too. So it becomes a community question board. And at any time somebody has a pressing question, they're like, oh, me, I want to say now in the middle of your conversation. And I say, oh, please keep that thought, put it on the board. We will keep it and we will answer it later, or maybe now in a moment, just put it there. So you can have group discussions okay, there are some questions here on how to teach this or that topic. This is too detailed for now, but what if we have, this one is better to deal in a teacher forum, where people can come together and discuss their favorite ways. So ask your math friends, find the teacher forums, there are some good ones. Form your own support group, and that's how to get good materials for particular topics. One more question I'll just pick from the chat. Can we teach real calculus to a child of age 5? Okay, I get this one a lot. So I'll address this. When people say real calculus, they probably mean a calculus course from college that you can take and pass, or from high school and some places. Please don't do it to 5-year-olds. Even though some can, it's not the age related, it's too formal in that way. And then there is a question even, should we be teaching college students at that formal level too? Because a lot of people flunk that calculus or suffer through it. So what we teach at 5-year-old, at 5, is hands-on, playful calculus as a point of view on life. Some things in life, so I will have more examples, but imagine that a toy, something play you can do with your child. I say, hey, let us walk together, but we will walk in a funny way. We're trying to reach that wall. It's right here, a few steps away. We will go half the way there and stop. Okay, walk with me. We will walk half of what the distance is left and stop. We will walk half of what is left and stop. And some of you here recognize this as Zeno's paradox. The child soon says, oh, we'll never get to that wall. Or someone says, oh, I get close enough. I can touch it now. And that's kind of how you do this idea that you can add smaller and smaller pieces and it will add to close enough to the whole distance. Hands-on ideas, we can teach these models. We can teach children what infinity is, and what tinier and tinier and tinier pieces can add to. They do understand the concept of a limit at 5, and these are very powerful ideas that will help them going on. So that, I hope, answers the question. I am going to give another piece of my presentation now. Thank you. And I will collect the questions from the chat. And I will try to address them somehow. So if yours didn't get answered, we'll try to do something with it later. That's a beautiful, these are all beautiful thoughts and very valuable. So I'm going to continue sharing my presentation and talk some more about my stuff. So where is it? Slideshow. Here it is. Share. So we stopped at Design for Love, and that's one thing Matific does, and many of you do, I hope. And I'm going to click here and continue. So the second reason I love Matific, and something else I love about design, is that idea of easy complexity. And I will make some examples of what I mean about easy complexity. We will talk about this. Try this. You can try this now if you have paper and so on, or you can try it in a bit with your students or with your children, or play for yourself. So it's accessible advanced math. It's different from teaching them what triangle and circle is, which we also do, or what 2 + 2 is, which we also do, and that's important. This is a design where we take advanced mathematics from our math friends, and we make it accessible, just like this child is doing ballet, even though she's not this famous ballerina. Okay. These are some of math friends who are doing advanced stuff. This is Dr. Melissa Kibbe, and she has a lab called Developing Minds. So if you are familiar with the movie depicted in my picture, which is The Wizard of Oz, and of course you will want to, if you do that game, you will want to use a story your children are likely to know, some fairy tale or folk tale or a favorite movie. And you hide one toy out of 4. In here, there is a character under X. And if you really know that movie, you know it's a scarecrow, right? And if you don't, then you don't. Then what you do is you take a picture and show to children, and then you hide one thing in the picture and say, well, what is X? What is hiding there? So you can try playing equations like that even with 3-year-olds. So you go from that toy equation, what is hiding, hide and seek. And then you go to, well, here is a funny dog and shoes, but I hid some of the shoes. How many shoes are hiding? And so a child I see jumping here can probably answer that question. You can ask them, how many shoes are hiding? They can say that. And here I have a quote. Again, it's better if children know the saying. That's a quote from a famous physicist saying, give me a fulcrum and I shall move the world. That's something, if you know the quote, you can say. And that's the same way you can go to formal equations. So that's how you can play equations starting with toddlers and going on, toddler algebra. And that's what Dr. Kibe is doing in her lab, doing algebraic reasoning with very young children. So, okay, profession is origami theorist. And that's something I tell children when I say, oh, mathematics is in cool places. So that's Dr. Robert Lang, and he works, he's a mathematician who works for NASA. And he studies origami, paper folding. Paper folding as a hobby, but paper folding as his art, his craft, his math. And he's doing artistic stuff too. So this here is a giant solar sail. Of course, you don't want to launch it like that from Earth. It's too wide. It will burn in the atmosphere. The thing he's standing in front of is a telescope, and the way they launch it in space, they fold it like origami. And if you want to play with children like that, you can do a lot of paper folding. Between the Folds is a movie about origami. You can watch it, you can find it. You can do some paper folding with children, and it's very easy to start on that play, and it gets complex very fast. And you can talk about people using it. So that's playful modeling. That goes a long way to making it joyful. Okay, one more hero, math friend, Vi Hart. She calls herself math musician. She's a mathematical artist, and she designs games, she makes art and makes music. So she makes very inspiring things. If you search for her videos of her games, share them with your students. They're beautiful and students love it. Very friendly stuff, some fractal stuff like I was showing you. And I use her fractal videos, which are beautiful and have millions of views on YouTube, to do those fractal activities I was telling you about. So here are some very young children making fractals with inspired by Vi Hart. So you can try that at home as well. So one more math hero, Hans Rosling, he designed the tool called Gapminder, which is applied social math tool. If you work with middle or high school students, use the tool. It's really great for data analysis. It's very appealing, very accessible. His profession, self-described as data superhero. He's a statistician. He was, you can play data like this. You can measure the sizes of the universe. You can start measuring with your hands. Here are some children who measured with their hands, one hand, That's about my cell phone. 2 hands, that's a book. Double that, 4 hands, that's a lamp. 8 hands, that's my dog. 16 hands, that's me. That's how tall I am, this little girl probably can say. And so on, and then you get to the galaxies pretty fast, actually. Children understand that. That's an accessible way to study exponential growth, multiplication, and scale. Somebody even asked in chat about some of these topics. So I wanted to share this diagram made by my teen when my kid was young. And what it claims here, it takes a bit to read. But what it says here is some of the things are not opposite. Well, hard and complex are contrary to one another. They kind of go together, but they are not the same thing. My favorite example is, imagine digging up a pond for water. A lot of villagers do that. They dig a pond. Imagine doing that with a teaspoon. Well, that would be hard, but simple, really. There is nothing difficult, complex about digging a big trench with a teaspoon. It's just simple but hard. So complex and easy here in particular are complementary. And that's the design for young children. You design for that complexity, for going deep, but you design for ease as well. So sense of ease, hands-on modeling, emotions, emotional support, that's what you do. And that's how you get these things. So that was me sharing about easy complexity. And I'd like to pause again and invite questions. So as before, okay.
Doctor, I have a couple of questions, which is a show of hand. Let me request them if they can ask you, otherwise possibly we'll ask them on the chat window. Garima Shukla, if you can unmute yourself and ask the question if you have. And I have been reading the questions, guys. Garima, please go ahead. Yeah. Garima, you had unmuted yourself. Sandeep, you can ask your question, please. Sandeep Singla. Sandeep. Yeah, Sandeep, go ahead, please.
Yes, good evening, everyone. Ma'am, I want to ask a question. How we correlate the concept of polynomials with the real life mathematics and with the real life events? Concept of polynomials especially, I am facing some problems to correlate this one to our real life concept. So please help us in telling how to correlate it.
Okay, so this is again an example of question as particular topic. How do we make that topic shine? How do we model it? That's really great with a teacher support group. So once again, I urge everyone to be on some teacher forum where you can do this with math friends. So for polynomials in particular, I really like modeling tools such as Desmos, and I love online modeling tools. So let me briefly invite you to model together. I'm going to screen share my screen, and we can again ask. Let me just share the whole thing. We can ask children to bring an example, or we can start with our example. For example, such as, well, let us take a piece of paper and measure your favorite number, an interesting choice. Measure out on the side 3 centimeters or 5 or 10, and then make a square that large. How many square centimeters are in it? And then everybody will have different squares. So if you had the square with 3 side of 3, it will have 9. It will have 9 square centimeters. And if you had the square of side just 2, well, of course, it will have the area of 4 square centimeters. And if you had 4, well, of course, that's 16. And I have to zoom out to show this particular point. And then I can say, well, there is something I can do to hit this line, all of those dots together with one line. And I put this here, and all the dots are on the line now. And that line models the situation. So that's how I like to teach modeling. First, very hands-on. Let's make things out of paper, make things that we bring, find the way to do this, to physically make it. And then do it example by example by example, point by point, and then go into graphs and abstracts. I hope it answers the question. Gaurava, do you want to pick another one? Anyone with hands raised?
Garima Shukla, please ask your question. Garima, do you have a question? No. Shivani Lodha. Shivani.
Sir, I have a question. Myself, Garima, because of poor network, there is issue. Hello?
Yeah, go ahead. You have a question?
Yes, ma'am, I have a question. Ma'am, I have a question that my question is related to the present scenario. Like we are taking online classes and all, and to how to make sure the involvement, these activities which you are telling, we can involve the children. But right now I'm teaching a topic in 6th standard integers, and it's quite difficult for me to how to involve those children for the teaching tactics. Means what should we do for that? Means how to make it more easier, and some tricks for us, for some techniques what we can use to making the study learning process more easier for the students as well as for us also.
So the question is how to involve people in a particular topic that you have to teach to the standard.
Ma'am, right, in the present scenario, we are going for online classes. When we go for the classes physically, we see the involvement of the children. But right now we are going for the online modes. So how to involve them as much as possible and make them the concept much easier, interesting?
Okay. Oh, that's a great question. And as you know, we are on lockdown here too. So we're in the same boat. I've been teaching online for about 20 years now. I love online. I started back when the internet was young and small and was already teaching online. So with online teaching, it has some opportunities. As we are doing now in parallel, find ways for every child to be active at once. That's even more important online in virtual environments. You can have groups of children, even a large group, work in the same spreadsheet when it's shared. You can have invite children to doodle in the same board. You can invite children to work in parallel. So imagine I do this a lot with children online, and hands-on can still be done online. So I'm going to highlight myself now and show you a thing with paper where we can do that with children. Imagine every child doing this. If you have paper and scissors handy, which I didn't tell you to bring, I should have. If not, you can just imagine. So imagine every child doing this and I say, hey, let's lift our papers, everyone ready, yay. You can do that part at least if you have paper. And then, okay, let us fold it in two and do this together. Use different tools, use different hands-on techniques. So you model, but children are modeling with you. So they show to one another. They say, oh, I do it this way, that way. So you do it this way and children are show. You can spotlight different people. So if Goarava was doing it with me, I would spotlight him for a second and show his paper and go to the next child. And then we would fold and try and cut and try to have activities where they have some choices so their outcomes are different, like pick your favorite number and substitute it in that polynomial. What is your multiplication example? Write it out. What is your model? So I am going to cut out some curves here and some shapes. What is your shape? Well, I'm cutting out the triangle and then it doesn't come handy, and then I'm cutting out a diamond from that end and maybe a big kind of teardrop here and maybe a square there or a rectangle at least. And we'll see, yes, rectangle is more like it. So if I do this and every child, imagine every child doing it slightly differently and it will be a slower activity. But when I open it up, look what happens here. I made something, I made a model and I can ask questions about, well, how does this multiply? How, what shapes did I make? How they came from? And then I can highlight another person and invite them to show their model, to show their snowflake, to show their example. And everyone is working in parallel, but people know they can have a chance to have their voice to show their creation. And that's what makes it interesting for them, when their voices are heard. And online, you have more chances to make it so, because we can work in parallel and in this shared spaces. So a great question about that. I'm going to, okay, somebody's asked my favorite question, I can't resist. How can we correlate integration and differentiation with real life? Okay, and I imagine you wanted something that a 5-year-old can do, right? Or somebody, see, okay, secretly, I'll tell you a secret. Okay, it's not really a secret, but I'll tell you it as if it were a secret, because it's one of those things that we know is true, but not necessarily use in education. If you work hard as a teacher and teach in such a way that a 5-year-old can understand, that dramatically raises success of your older students, your grown-up students, your college students, what have you. It's a matter of equity and accessibility. Doing some very accessible examples that even a 5-year-old can understand means everyone can understand. Parents, grown-ups, anyone, and that's an important thing to do. So how can we correlate integration with real life for 5-year-olds? Okay, I love Star Wars. I have to confess, I used to more, especially 20, 30 years ago as a child. So I'll use an example from there. There is a ship called Millennium Falcon, and it's very round. I'm going to show it to you. And I'm going to show it to you. It's this beautiful round, hold on, screen share. this. Yes, that's a round ship in space. And I can ask you, well, if I have a box of Lego, just Lego blocks, can we make that ship or something like that ship out of our squarish blocks? So an easier question is, of course, here is a box of Legos. They are just cubes. Or even I give people cubes like this, unit cubes. And I say, well, can you make a round circle, a Millennium Falcon or Apple or anything else round that they like out of this squarish blocks? And of course they say, well, let me try that, and they try. They approximate the circle with squares. I think they can in different ways. And of course their circle is kind of roundish and kind of good. And some say, yeah, that's good enough. And others say, nah, look at those jagged edges. The edges are all wrong. They're not really round. And then I tell them, well, imagine in your head that you had smaller cubes, just to make the edges smoother. Can you imagine using smaller and smaller cubes to approximate those edges? And they're like, yeah, I guess. And we could make a pretty good circle if we use smaller squares. We could make a pretty good sphere if you use smaller cubes. And that's what integration is. You use shapes. You make shapes out of other shapes. You use cubes to make a sphere. You use an apple. You use squares to make a circle. That's integration. And you can teach differentiation in similar ways to very young children, make it very accessible. I want to suggest there are accessible materials for every topic. There is a quote Brunner said in the 60s, you can teach any topic to a child in intellectually honest form to a child at any stage of development. That's a very radical statement, but I believe you can teach any topic in some intellectually honest form to a 5-year-old most of the time. And we should try. Okay, I think maybe one more question. Do you use Legos? I love Legos. I use them a lot. I only use, okay, I have a box of just 2x2 Legos and nothing else. Not the fancy figures, not those difficult levers and so on. Just plain Lego cubes. And I use those for building a lot. They are almost more creative than Lego kits. And thank you, everyone. The questions are wonderful. I've been looking through that. It's super inspirational. We will collect them, of course, and we will share that part. This is being recorded. Okay, so someone asked about mistakes. Children copy things wrong, make silly mistakes, and in calculation, what do we do about this? I have this concept of math friends. And I invite children to edit, to do peer review, like the grown-up researchers do, and to ask for help of math friends. So when children copy hands-on stuff, sometimes you need to teach them how to hold the ruler, how to hold the pencil, and so on. And these skills are very good for mathematics because precision modeling does help, but do that gently because nobody likes to be nagged about precision. Instead, we do this, oh, let us try this again with math friends. Can your math friends, let's help our math friends. So we go around and children help other children and they check the answers for one another and that empowers them. They really feel like they're helping and caring and making the room, their little group, a kinder place. But also they learn a whole lot because not only they need to understand the correct, but they need to understand what this other kid did wrong. And that's a mathematically sophisticated piece of work. So that helps that. Okay, how do I use Matific app in my math class? So you can get a trial now. The site explains what to do, and the site has excellent tutorials too. So you can go there. Should we teach a child abacus? Okay, when people say should we do this one thing or not, if you love abacus, if you know good activities for them and you want to share, I want to encourage people to do that. If that's a part of the tradition, it's a great model. It's a hands-on model of our decimal system that really revolutionized historically how people did math and science and technology. So it's a treasure. It's historical treasure. It can be used to study history. It can be used to study traditions on top of, so it can be led to very rich activities. If it's about like, let's drill people to be very fast and push for that, these days, most children probably may not want it, but some will, so that can be an option. So that depends on how much you love this thing. If you love the thing and you want to share that and make these connections for your students, I think can be very valuable. How to take fear of math from children? That's a great question. I get to hear a lot of grief stories about fear and people fall apart and I have to do some therapy. And fear, yeah, that's, okay, yes, you can cry with me. I'm sorry you were hurt. And I have to say that's a bigger question and I blame the society for that. It's not math that people fear, but being tortured with it, being made to do things they cannot do with inadequate support, and math as a gatekeeper that is used by society to stop people from achieving their dreams. And while that is beyond the classroom, I think acknowledging these bigger issues and just saying, sorry you feel this way goes a long way, and then being brave together. How can we make a kinder society where children are not afraid of beautiful mathematics together? Have this discussion with children. What helps you? I asked that question of my group once. I said, what will help you not to fear math, feel better? And I expected things like, oh, give me more support for problem solving, maybe let me use a calculator, explain better, you know, technical stuff. The number one thing people said was, can we have snacks? And that just blew my mind. Snacks, food. And we started to have snacks every meeting. And turns out I later learned about it. I went and learned that mathematics burns tremendous amount of calories. And then the sugar crash happens, and then people have this physiological anxiety response. So making sure people are not hungry goes a long way toward not fearing mathematics. And that's something to be accomplished.
Interesting.
Interesting, unexpected. I totally didn't know that, so I'm telling everyone. And I want to say there are several people saying, we are at the end of time for this session. So I want to invite you to do one thing in the next 1 minute. I would very much love it, and it would help a lot of people too. If we will be silent for half a minute, And then please type in the chat the one thing that was useful for you in this session, useful, beautiful, or joyful, what you think will help you, and that will help me a lot, and I would appreciate it. I want to thank everyone for the question. So 30 minutes of silence, not minutes, seconds, meditation. What did you like here? And now type what was useful for you here. One thing, just a thing. Type it and put it in chat, please. And we will, while you're typing, we will wrap up at that. Gaurav, that's to you now while people are typing.
Okay, so I would, there are a couple of questions which are coming on the show window. Let me just quickly, Shweta, you have a question. Kindly unmute yourself and ask the question. I have unmuted you. Otherwise, if we have, I think you've got a lot of response on the chat window, but this is largely our last half of this session, which is that if you have a question, you can have a show of hand. Mostly put it on a show of hand because then it is far easier for us to understand who is asking the question. Then I can unmute you and then you can ask your question if you have a question. Otherwise, obviously, you're aware of that IPN has tied up, in fact, with Matific. And all of you who are part of this session can avail a 60-day of a free trial for all of yourself, which is completely no cost. Okay, so we will get that communication going to all of you through your leaders, your principals. Once they have filled in the expression of interest form, you can avail the sort of a literature you can from the Matific platform. And apart from that, I think Dr. Maria has also some wonderful, interesting sort of links I could see from her profile, which I will also get it shared with all of you, which is, I think, the natural math thing is a very interesting stuff. A lot of resources there. Any other question? If we have...
Let me just say one more thing before we go. Naturalmath.com is my site, and we've been online since '96, an old site, almost 25 years, and all the materials are Creative Commons. You're very welcome to come and take this stuff. And you can translate it, you can print it, what have you. So we have a lot of books, and people had a lot of questions about multiplication. We do have a multiplication course developed, and there are different things like that there. So naturalmath.com is where it's at. And Matific is, of course, partnered with IPN, so you can access it and you can get wonderful games from Matific and support and teacher exchange, all the good stuff. So
perfect. So this has been a wonderful session, and actually I think 1 hour was too less, Dr. Maria. So I think we will end up inviting you once again, possibly sometime soon, on a different sort of a topic. But thank you very much, everyone who had joined in. I hope this session was valuable for you. Do give in your feedback to your school leaders and principals who are here. Possibly send in your teachers who were not able to attend this session the next time, possibly. So thank you very much, Dr. Maria. It was great having you with us. Very early morning in the US, yet you were looking refreshing. So good to have you. Anything? Over to you for the last words. Yeah, please, ma'am.
Thank you, new math friends. Let us stay math friends. That's what I say to my 5-year-olds, math friends. So I call everyone that. And let us do things together. And I hope you support your children. It's been wonderful to see your thoughtful questions, to see how caring you are, to hear your voices. And I love doing this. Let's do this again. Absolutely. I will get up at 5 for this any day. So thank you. Stay wonderful, everyone. Stay
Thank you.
wonderful as you are.
Thank you, Dr. Maria. Thank you, Dr. Maria. Take care. Stay safe. Stay healthy, all of you. Take care. Bye-bye.
Bye-bye.